Okay. This is redox reaction, net ionic shortcuts, woo, part 1. All right. What you're learning in the next few days, today and tomorrow, and then tomorrow night's homework is hugely important, your weekend homework. So you want to make sure you try every one of those problems and come see me if you have questions. This is, to me, amazing. You can write a redox, totally a net ionic equation without 3 steps. You can do it in 1 step, and it's so fast. And it really shows that you truly understand chemically what's going on with the reaction. That's why I really like teaching this. We're going to do this strictly with redox reactions, and specifically with these 4 types of redox reactions: single replacement, combustion, decomposition, and synthesis, also known as addition reactions. Okay? Redox is occurring in every single one of these. So everything I'm going to talk about now is showing you what you need to think about when it comes to redox and charge changes and all that kind of stuff. So here are some tricks of the trade that over the years myself and my mentor teacher, he actually started with this. We've developed this method, which seems to be really cool, and it works. If you're not asked to write the total ionic equation, then you can do this, okay? It's only, sometimes they will say, write the molecular, write the total, cancel out spectators. They'll demand all of it. And on this test, you're going to have to be able to do both. So your first trick, never ever write down group 1 or nitrate ions. Why? They're just going to be spectators. Now, there is an exception to that. If a problem says solid sodium chloride is added, they're telling you it's in solid form, so you have to write NaCl. Okay? If they say sodium chloride solution, you have Na plus and Cl minus, right? So you can just write down the Cl minus. You don't even write down the Na plus. Got it? All right. The next rule, make something go up in charge and something go down in charge. You're going to be sitting there looking at these ions going, what do I do? If you recognize that it's a single replacement, combustion, decomposition, or synthesis, you know it has to be redox. So you can make something go up and down. And it's really, really cool when you figure that out. Go to metals first. That might not make sense now. It will when we get there. But when you've got 4 ions staring at you in the face, a metal, a nonmetal, a metal, a nonmetal, and you need to make redox happen, go to those metals first and see if you can make one go up and one go down. And if you can, you're going to go with those. And then finally, make sure your charge and atoms are balanced. A lot of students, they'll see all these things and just count atoms. The charge has to be balanced as well. And so we're going to do some practice. But again, I state again, if they're asking you for total, you got to do it the old-fashioned way. All right? So let's go ahead and look at single replacement. Single replacement, remember, is when something comes in and boots something out. The charge change happens because we're going from something at a 0 solid state to something in a compound, so its charge is going to change. And the thing that's booted out, its charge is going to change, and so that's why these are redox. Okay? Now let's read what it says. Note, be very careful when there is a metal being added to water. When you're adding a metal to water, students will more often than not make the wrong products. This is such a big deal in the AP. They often do metals added to water that I call these push-up problems. If you get these wrong, you will be doing push-ups. Physical punishment, yes. Okay? So I'm just telling you this because I want you to pay attention. Metals to water. What students tend to want to do is to just boot out that H and make some sort of metal oxide plus hydrogen gas. That's wrong. Wrong, wrong. What actually happens, you're going to write water as HOH. If you write water as HOH, what happens? What do you make? Your metal hydroxide plus hydrogen gas. So anytime you add a metal to water, you make a base and hydrogen gas. You make a hydroxide and hydrogen gas. You just have to remember that, okay? So be careful. Don't make an oxide. You make a base. Okay, So let's jump into doing the first one, and I'm just going to lead you through it and ask you some questions. A piece of aluminum metal, what am I going to write down? Al. Is added to a solution. It's telling you it's the solution. So what is it in? Right, and it's broken down into ions. So there's two ions there, a silver and a nitrate. What am I going to do? Only write the silver. And one thing I'm failing to mention is you do not need to include states of matter. Not necessary. Okay, so I'm not going to write the nitrate down. I know this is single replacement, right? Aluminum is booting out the silver, so I know this is redox. So I know something has to go up in charge and something goes down. Going to my metals, can I make one of these go up in charge? Which one? Aluminum can go to +3. Silver can only do one other thing, and what is that? Go down to 0. That's why you need to know your charges really well, okay? So this is where balancing is important. A lot of students say, oh, I've got one of everything. No. I've got a balanced charge. So how do I make charge balance? I got to make 3 silver. So now I've got +3. But now what did I do to my silver atoms? I need to add more silver on this side. And now that is a balanced equation. You could do half reactions. I heard people say, add electrons. You could have. But what you would have to do then is to pull out and go, okay, Al going to Al +3 electrons. And I've got Ag +1 electron goes to Ag. And then I'd have to multiply this by 3. So I get a 3 here and a 3 here. So you get the same result. Okay? So if you're stuck and you have trouble balancing it, you can balance using the half reaction method if you have to. Okay, small chunks of solid sodium. What's a small chunk? It's a solid. So sodium. You write it down because it's not ion. It's not a sodium ion. It's just sodium. Added to water. Since we're adding a metal to water, how are we going to write it? HOH. It's a liquid, right? So we leave it together. What are two products? Don't write NaOH down yet, though, because we got to follow solubility rules. What happens to NaOH anytime it's in solution? It dissolves into ions. So we have to write NaOH like that. Why can't we just get rid of the sodiums? Yeah, they're different charges. They're not spectators unless they're exactly the same, right? And then, what's our other product? Plus hydrogen gas. So now what we'd have to do is balance. So this one, I know that I have 2 H's, and that's this H. So I'm going to put a 2 there. So I'm going to need 2 OH's, right? And that looks balanced, but it's not charge balanced. I have a +3 on that side and a 0 on this side. What can I do to fix that? Not a +3, a -1. I have a -1 here. What can I do to fix this? No, we're not adding electrons. We're just going to use the things. What? Add a sodium. So now I have a 0 charge, and then I need 2 sodiums on that side to make it balance. Okay? The only time you add electrons if you're doing the half reaction method. Okay? All right, 2 more to do. We've got plenty of time. Chlorine gas, what do I write? Is bubbled into a solution of sodium bromide. What do I write down? Do I write down Na+? It's a group 1 metal. I'm not even going to write it down. You can, but you're going to end up canceling it. So don't write it down. What are you going to write? Br-. Okay. This is chlorine gas booting out bromine. It's a single replacement reaction. So we need to make redox. This is really a cool, easy one because something goes up in charge, something goes down. Both of these are diatomics. Those are halogens. They have the same charges when they're ions. So what happens? What? What can chlorine do? Chlorine's a 0. Can we make it go down? To a -. Yeah. Can we make bromine go up? Up to 0, right? So it's Br2. And now to balance it, 2 bromines, 2 chlorines. Oh, and my charge is balanced. Now, do you see how much faster this is? Like, if you don't believe that it's the same, go do it the old-fashioned way. Put your states, molecular, split it up, cross out spectators. I promise you'll get the same answer. Okay, last one, and then we'll call it a day. Magnesium turnings. Solid. You know what a turning is? Have you seen a block of cheese, like on TV, and they pull the little thing that cuts the cheese, and it rolls, like it's like a curl? Like you run the thing across and the cheese curls into a piece? That's called a turning. So I have a bottle of magnesium turnings that are just all these little magnesium curls. Okay? So that's a solid. Magnesium turnings are added. Now here's where the whole gold medal first thing is important. We have to write down both of those as ions because halogens aren't always soluble, and iron 3 is not always soluble because it's not a group 1 metal ion. So we're going to write down iron plus 3 plus the chlorine ion. Now whether or not we use them all, we don't know yet, but we'll talk about that. We can put 3, yeah. We can put 3 there. I tend to balance at the end, but yeah, if you want to do your 3 right away, that's totally okay. All right, so looking at that, this is where go to metals first is the golden rule. Can I, looking at just the metals, make something go up and something go down? What can go up? Magnesium can go up to what? A +2. Can iron go down? It can go down to a 0, or it could go down to a 2, right? But always take your metals to the 0 state. So iron's going to go down to 0. What did you say you didn't think you could, Bree?
Well, I thought because like it's stock, because iron stock is like you can't
No.
mess with that.
No. Stock is, that's titrations. That's just a different world.
Okay.
So don't worry about that. This is a redox reaction. Okay? So, and even in a titration, redox can happen, but stock is just a term meaning we know what its concentration is. It doesn't mean it can't react. Okay? So, did I need the chlorine to make redox happen? The chloride ion. Bye, Felicia. I just had to say that, sorry. Okay, now we got to make charge cancel out. I mean, not cancel, be the same on both sides. So, yeah, we need a common multiple of 6, it looks like, right? So if I put a 3 on magnesium and a 2 on the iron, that takes care of the charge, but then I need 2 irons and 3 magnesium atoms. Okay, so let that simmer overnight. Your homework tonight is only on only on balancing, right? You won't do the homework over this until over the weekend. Yes, Naira? We didn't need it. It's a spectator. So it didn't create a solid on the other side. Okay, it didn't react with, it's not a double replacement. It's only if it were double replacement we'd have to question what the deal is. Okay, are we good? All right, see y'all tomorrow.